This lecture is covering Unit 5C, Statistical Tables and Graphs. So we've talked about statistics and how the purpose of statistics is to take a small amount of data and apply it to a large group of people or objects. Well, one of the things you've got to be able to do is how do you represent that data and how do you show kind of what it means? So some of the easiest ways to present data is in the form of either a table or a graph. So the first one that we are going to cover is a frequency table. So here is a list of grades that a teacher gave to 25 of her students on an essay. So the list contains all the grades. It's really not that easy to read. I mean, we've got an A, C, C, B, C, D, C, D, D, F, D, okay? And so if you're to look at it, it's kind of hard to get a feel for how the class did overall. And so one thing would be to just put it in a frequency table, and that's what we have over here. So if we look at the table, we have 4 A's, 7 B's, 6 C's, 3 D's, 2 F's for 25 total students. Much easier to kind of get a feel for the class, see how students do, and you can make your decisions on that afterwards. So a couple of basic things on a frequency table. The first category, or the first column, is going to list the categories of data. So in this case, it was the grades. So A, B, C, D, and F. The second column lists the frequencies. Okay, this is going to be your data value. So 4 A's, 7 B's, 9 C's, so on and so forth. So a couple definitions. The relative frequency is a fraction or a percentage, it doesn't matter, of the data that falls into that category. The cumulative data is kind of the running total of that category and all previous categories. So if I kind of add 2 more columns, we're going to add the relative frequency and the cumulative frequency. So you can do either one for the relative. So for A's, there was 4 out of 25, or 16%. B's, 7 out of 25, 28%. C's were 9 out of 25, 36%. D's, 3 out of 25 for 12%. And F's were 2 out of 25 for 8%. For the cumulative, it's going to be a running total. So for A's, it's 4 out of 25, 16%. For the next one, it's going to be A's and B's. So 4 A's, 7 B's gives us 11 out of 25, or 44%. If I throw the C's in, there's 9 more of them. That gives us 20 out of 25 for 80%. 3 D's puts us at 23 out of 25, or 92%. And the 2 F's put us at 25 out of 25, or 100%. All right, a couple things to note. These numbers here, whether it's the fraction or the percentage, doesn't matter, but they need to increase. These values are going to be going up, and this last value has to be 100%, because you're going to have all of your data included. So there's 2 types of data. There's qualitative data, which is the qualities or the categories. There's quantitative data, which is the number or the measurements. So a brand of shoes would be a qualitative. You could have Reebok, you could have Under Armour, you can have Adidas. Okay, you've got different types. The heights of students, those are going to be values. 6 feet, 5'11", 5'2". So that's going to be quantitative. And then the audience rating out of a scale of 1 to 5, that is going to be quantitative. Okay, it's a measurement. Anytime you've got measurements or numbers, it's quantitative. Anytime you have qualities or categories, it's going to be qualitative. So another way we can do this is what's called binning the data. So when we deal with quantitative data categories, it's often useful to group it together. So here is 20 scores on a 100-point exam. Okay, much like example A, or the first example, instead of A, C, B, D, whatever, we are going to get a value number. Okay, so 76, 80, 78, 76, 92, so on and so forth. Okay, once again, a little bit tricky to use. And unlike the first example, I don't have an easy way to group it as an A or B or a C. So we're going to set up the data in bins. Now, when you're setting up a bin, you can pick the values that you want. The values have to be the same range. Okay, in other words, I can't go 5, 5, 10, 5, 6, 7. Okay, if I'm going to go with 5, I've got to stick with 5. If I'm going to go with 10, I've got to stick with 10. You need enough bins that the data is useful, but not so many bins that it's just like looking at the data. For example, I can't, for this value, I don't want to pick bins of 50 because that's going to include all the data and not tell me much. At the same time, I don't want to pick bins of, say, 2 or 3 because then I'm going to end up with 15, 20 bins, and it's not going to tell me any data anyway. Okay, so it's always a range. Enough bins that you can use the data, not so many that the graph is useless. So for this one, I did bins of 5. So 71 to 75 inclusive, 76 to 80, 81 to 85, 86 to 90, 91 to 95, and then 96 to 100. So in this case, there are 6 bins. Usually somewhere between 5 to 8 is enough that you can get a good feel for what you have. So between 71 and 75, there were 6. So that gave me 30%. From 76 to 80 gave me 6. 81 to 85 was 2. 86 to 90 was 3. 91 to 95 was 2. And then 96 to 100 was 1. Okay, so I set up my frequency. Okay, and then I did a cumulative as well. So 30, 60, 70, 85, 95. And then once again, it ended with 100. A couple other ways you can do it is you can make a bar graph or a pie chart. So a bar graph uses set-off bars to represent the frequency of each category. The higher the frequency, the longer the bar. You can do them either vertically or horizontally. However you do it, there's a couple things you've got to have. You need a title or a caption. You need a vertical scale and a title. Okay, you can use tick marks. Make sure that you are consistent. So once again, you can't go 5, 5, and then jump to 10. If you can go with 5, stick with 5. You can go with 10, stick to 10. Both horizontally and vertically. And then some kind of legend. Okay, so a list of what the data is. A pie chart is primarily used for relative frequency, and it has to add up to 100. The size of the wedge is proportional to the category it represents, okay, and the wedge angle is the relative frequency times by 360 degrees. So here is our assay data, and we have the frequency over here, the relative frequency on this side, just for reference point. You could do one or the other. In this case, we did both. I have a title, and then for A's, there are 4, B's were 7, 9 C's, 3 D's, and 2 F's. Okay. Notice there is a gap in between each bar on a bar graph. So here's my pie chart. So 16% got A's, 28% got B's, 36 got C's, 12% got D's, 8% got F's. And then you do a proportional grade. So you would take 16% times 360. That's what this angle here is. 28% times 360 gives you this angle. If you're going to do a pie chart, go ahead and get a protractor and a compass so you can make sure that things are proportional. All right, here are some goofs. Last week we asked if A levels are becoming harder to pass. Well, 49% said no, 50% said yes. First off, that doesn't add up to 100. Second of all, this should be a little bit closer to 50-50. In other words, it should come straight down. And the yeses better take up a bigger area than the nos. What grade are you in? Well, 26% freshman, 26 for sophomore, 26 junior, 26 senior. That's 104%, so we're over 100. Second of all, well, these are probably 26 and 26. This one is definitely bigger than 26. They all should be the same size. They're not. This is way smaller. This is just a total messed up graph to begin with. Same thing with this one. A third of our budget goes toward financial aid. 60 million, 20 million. That is not a third. That is a fourth. Okay. So the graph is right. It actually is a fourth of their budget because their budget's 80 million if they have it labeled correctly. And that would be a fourth. So either they screwed up and it's 60 million total with 20 million of it to financial aid, or 60 million goes to something, 20 million goes to financial aid. Not really sure, but they goofed. All right, so here is the number of tourists, international tourists per country. We're going to create a bar chart and put the bars in descending order. So we're going to go with the 2016 numbers. So France, US, Spain, China, Italy, UK, Germany, Mexico, Thailand, and Turkey are the top 10 countries for international tourists. So I did not put a title here, so that is a mistake that I would need to correct. I do have my values here. Okay, so each one of these tick marks is 10 million visitors. Okay, and once again, I should probably have a listing here. Okay, countries are down the bottom, so France, Spain, US, Spain, China, Italy, UK. Notice there's a gap in between, okay, and then each country gets its own bar graph. Okay. So be careful, make sure your data actually is good. 50 degrees is probably good, 49 degrees is probably good, 519 degrees is a little hot. All right, and then I just threw this in here because we're talking about tourists, and this is what every country in the world is known for. So the US, Nobel Prize winners, and getting killed by lawnmowers. So could go to Canada where they got maple syrup and the highest number of asteroid impacts. Australia, deadly animals. Sounds about right. All right, so here is a pie chart. So among the registered voters in Rochester County, 25% Democrats, 25% Republicans, 50% are independents. Make a pie chart. So half the graph is going to be independents, a fourth of the graph is going to be Republicans, and a fourth of the graph would be Democrats. Okay, make sure you list them. And I probably should have drawn that line up a little bit higher, but I was freehanding it. So should have had a compass and a protractor, but I didn't. So we went with what we had. This is what you should not do. Biggest COVID worries. 48% said getting it. That's not 48%. 62% said family is getting it. That is not 62%. 68% said the economy. That is not 68% of the graph, and that does not add up to 100. So that is another totally messed up graph. Do not do anything close to that. You will get it wrong. Should Scotland be independent? 52 said no, 58 said yes. Hey, at least the Scots are giving it 110%. Okay, once again, has to add up to 100%. So two more charts, ways to do it. Okay, a histogram, which is very similar to a bar chart. Okay, it follows the natural order, and the widths of the bar have specific meanings. And if you notice kind of the difference is there is no gap in between the bars. A line chart is very similar to a histogram, but you do a series of straight lines to connect the data points. So once again, we got scores on the bottom, frequency here, labeled, okay, with bars. Now the difference between that would be they are no gaps. Okay, and then same thing here, we've got dots and then the lines connected. All right, so here's our chart. For the age of the Academy Award-winning actress through 2013. So we're going to make a histogram and a line chart. So here's my histogram. So 20 to 29, 30 to 39. Okay, notice these are the same length. Okay, so I should have down here ages. I should have a title here. And then once again, this would be the number of cases. So 10, 5, 10, 15, 20, 25, 30, 35, 40. Okay, so make sure when you're doing these that you label them totally correctly. I didn't take the time to do that when I did this because right now we're more focused on the graph, but when you do a final product, make sure that everything is labeled. So 30, 34, 13, 1, 6, 1, and 1. Okay. For a histogram, it's going to be very similar. Okay, so 20, 30, 40, 50. Same thing, 10, 20, 30, 40. But instead of doing a bar, I put a point for the data values, and then I connected them using straight lines. Okay. When you're doing a line chart, make sure you do lines and not curves. Now, the other thing which you may have noticed is you have to start from 0. Okay. For example, the times. If I'm looking at the graph, the times looks like it's doubling or maybe even tripling what the Daily Telegraph has. Okay. However, if I look at this, it starts at 420,000 and it goes to 490,000. Okay, so this is skewed. These values should be much closer. Okay, if I was to start at 0, the difference between them would be negligible. Okay, so in other words, this way it's looking like, oh, the Times is getting 2 to 3 times what the Daily Telegraph is, when in reality, if I was to run this all the way down and started at 0, the Times would be here, Daily Telegraph would probably be like right here. Okay. So, kind of to show that, if I look over here, I do play chess. So this is my chess ranking, okay, for August and September. Okay. So if you're looking at this graph, I'm kind of all over the place. I dropped, I go up, I dropped again, I went up, I dropped, I went up. Okay, and it looks like I've had this huge jump. Okay. But if you look at this, the graph really starts here 1715 and here's 1925. That was my highest ranking at the time. Okay, there is a huge gap between those because I'm not starting at 0. The graph started at 1700. So if I did that same graph, okay, here's my data points, but I started it at 0, notice while my ranking did kind of go up and down for a while, there's not that much of a difference. Okay, I'm actually fairly steady in my rankings, but because I started at 0 here versus starting here, there's a difference. So you always have to start a graph at 0. Okay, otherwise you're going to be able to skew the data. Now sometimes they want to skew the data, but you don't want to misrepresent what the data says. For example, the Ohio unemployment rate. Well, first thing is they start at 11 and they go to 10%. Okay, this should go to 0. Second of all, well, this does show a drop from 11.9 to 11.7 to 11.5. However, this is 11. This is 11.9. This should be above this line. This should be above this point. This one should be above this point. Okay. So the only value that's right on the graph is this one. And it should be 0 because it will show that while the unemployment rate did go up and it's starting to come down, okay, it's not going to be as big a shift as what they're trying to make it look like. And the final thing, make sure it makes sense. Remember, for this class, we're going to use real data. Okay, if it doesn't make sense, it's probably wrong. Sometimes the values don't make sense, like the ones we had earlier where they added up to more than 100. However, sometimes the question doesn't make sense. Which should cost less, a gallon of milk or a gallon of gas? That is not a yes/no question. So this one does add up to 100, but once again, not yes/no. Should be gas for one or milk for one, or reword the question. Should a gallon of gas cost more than a gallon of milk, or something like that? But just make sure that the data makes sense, make sure your graphs make sense, and make sure your answers match the question.